this is Point on Pally again, and now that we've gone through the intro for what we're going to do with this character, let's actually get started on the rigging. So, the first thing we're going to tackle here is the bottom of the character, specifically this main area and the tentacles. Now, I want to start on the tentacles because it's going to be the more noticeable part of this character. But before I tackle the tentacle, I just want to place some kind of default joints here for the bottom of the character. Now, I had mentioned in the kind of outline for this character that I wanted to do kind of like a walking hips thing for the character, where each kind of quadrant moves like a leg on a quadruped. It basically just lifts up and moves forward. Something I wanted to test. So I think at least to place default joints or to place like a default setup here, I'm just going to place joints for each of the quadrants of this character, and we'll just kind of leave it at that until we're done with the tentacles. So I'm going to go into top view here real quick. Let me just resize that. And so here is just the base of the character. So I just want to place a couple of joints here in each of the quadrants. So something like that for this one. Hit Y to reactivate the tool and place one down here. Something like that. Let's turn on wireframe. There we go. So I'm just going to make sure these are kind of even with each other in the x-axis. Let's do 0.85, something like that. And move it a little bit inward like that. And we'll raise the joints up here so that they're a little bit more in the geometry. And I'll push this one back a little bit, something like that. And we'll just quick name these guys. So I'll call this left front quad, or call this quad front, name it like that. So the quad is first. Call this bind. Call this. Oops, no, I mean this is left quad back. And then we'll just mirror these guys over. Now this is a little shelf button that will mirror joints no matter how many I've selected. By default, the mirror joints tool only works on a single joint. I don't know why they haven't set that up for a loop yet, but all this is just a simple shelf button where it just takes the mirror command and puts it inside of a for loop. That's really all it is. If you don't use shelf buttons, or at the very least Python scripts, I would strongly suggest learning them immediately because they really do help you out in terms of making everything kind of go a lot faster here. Alright, so we've got the quad joints here. We'll kind of just leave them as is for now because I really want to start with the tentacles first and then we'll get back into here. So I'm just going to group these all together. And I'll just call this CT quad pad. I'll put it under the rig group, and there we go. Okay, so now that we've got the kind of base joints here for the lower body, let's start with the tentacles. So we talked about how we're going to set up ribbon rigs for all of these tentacles. And the first thing you need to do is actually physically create the ribbon. So we'll go to NURBS primitives, plane, X-ray here, bring it forward a little bit, and we'll create some patches in the B-axis here. Start, well, 18 looks like it might work. So we'll scale that down a little bit, lengthen it so it's about the length of the tentacle itself. A little bit more. Something like that. So let's bring it so the right part of the ribbon is right at the end of the character. So that looks pretty good. Looks like the base of the tentacle, or base of the tentacle is in line with the ribbon here. I might make it just a teensy bit bigger. There we go. Pretty good. So freeze transforms on this. Call this CT tentacle 1 ribbon. Alrighty. So as far as how we tackle the ribbon from here on out, there are really two avenues of approach when it comes to setting up the ribbon, especially if you're going to be using nonlinear deformers as blend shapes on it. The two ways you can really go about doing it is setting up the tentacle as it is right now, perfectly flat. You would duplicate this and use these for blend shapes. Set up the ribbon rig with the follicles and the joints and all of that. Set up the controllers to move the ribbon around, and then you would adjust the controllers to move the ribbon so that it curves a little bit and lines up with the geometry. Because right now this is obviously too low here. Even if I were to rotate it a little bit and try and get that into position, looks fine over here, but right as we get towards the middle of the tentacle, it's becoming way too low, and we need to curve this part of the tentacle up so that it or curve the ribbon up so that it's in line with the tentacle here. So first option is to set it up perfectly flat. The second option would be to actually curve the tentacle, or curve the ribbon right now, currently, and then we would set up the ribbon and duplicate it, and it would be curved by default. We wouldn't have to move any of the controller objects or anything like that. Now, both avenues of approach have pros and cons. The pro to setting up the ribbon perfectly flat is the deformers on the blend shapes will set up perfectly because it is flat. We don't have to make any sort of adjustments to where the handles are for the deformers or anything like that. And it'll be a lot easier to set this part up. Whereas if we curve the ribbon right now, the deformers are going to be a little bit off because of the curved nature. And so when we set up the deformers, we'll have to make some adjustments. We'll have to translate and rotate them so that they're close enough to the right position. And even so, it may affect how the ribbon will move with the deformer if it's a little bit curved. Now, I don't think it's going to be curved as much, or it's going to be curved drastically, but still we may run into that problem. Now, the con to setting it up perfectly flat and then moving it into position is the blend shapes are additive to the rigging setup here. So the problem is, if I take these controllers after it's all set up here and then move it into place, the blend shapes that will eventually move this original ribbon will be added on top of the movement that we've already made here. So that may affect how the blend shapes move the geometry. So this part of the ribbon may not move correctly because we've taken that controller and moved it up. So the blend shapes are going to work additively along with that change here. Whereas if we build the ribbon with the curve by default and then set up the ribbon and duplicate it and all that, those additive effects of the blend shapes won't be there. So both setups have their pros and cons. And personally, we're going to go with the second option here, where we curve the ribbon by default and then set up the deformers and all that. The reason is the curve's going to be not too drastic where it's going to cause a lot of problems, and the additive effect of the blend shapes when you move the controller when it's built perfectly flat, you can't fix that. Whereas adjusting the deformer handles when the ribbon is curved, that you can work with, whereas the problem with the additive blend shapes, it's not really going to work all that well, and there really is no fix. So I would rather just set it up with the curve at default. I know that's kind of sacrilegious because every other ribbon setup video that you see, it's built perfectly straight. But personally, it's not going to be curved enough where it's going to cause too many problems. So we're going to start by rotating this guy a little bit here just to get it in the right position for the lower part, or for the end part of the tentacle here. So that's looking pretty good. So at this point, we need to curl this part up here by the root of the tentacle, and we're going to do that with a nonlinear bend deformer. So we're going to rotate this into the right position, and I'll use the side view here so I can line it up as close as I can. And then I'm pretty sure this is on an angle. Yep. So we're going to rotate this up like that. And we're going to turn off the high bound part, or in this case the low bound part of that. So we're only bending this part of the tentacle. I may even move it, adjust it a little bit. Bring it up a little bit so this part gets curved, and then take the curvature down a little bit. Let's put a little bit more central in the tentacle. So that looks pretty good. Looks like it's a little bit more inside the tentacle, just like that. Something like that. Looks to be pretty good. Alright, so now that we've got that kind of in the position that we want, delete history on it. I may even rotate it ever so slightly. Just bring it up just a little bit. There we go. Pretty good there. That might be just a little more curved than I want. So bring the curve down just a little bit. Delete history. Now rotate it up. There we go. That's pretty good. Try and be as precise as you can with it. Alright, cool. So now that we've got the ribbon in the right spot, now we can create the follicles and the joints. So creating the follicles is really easy. Just go to Effects, End Hair, Create Hair. Make sure the V count is the same as the number of spans in the ribbon. But if you're building this from a side to side, like if the ribbon is going in the x-axis here, you would put them in the U count instead. We'll just create hairs. There we go. So we don't need the NURBS curves here. We can just delete those. In fact, we can just delete that whole group. And then we can delete the hair system. We can delete the nucleus. All we really need are the follicles here. And I'm going to get rid of these little curve groups that are underneath here. So I'm just going to click down and then to the right. So it's selecting those curve empty groups there. And now you can see they're all gone. Alright, so at this point we can add the joints. Now, normally what you would do is you just create a single joint, parent it underneath the follicle, rename everything. What I'd rather do is build a script, and that's what I've got right here. So this is just a quick script that I made prior to this video that is just going to rename the follicle to something a little cleaner. It's going to create the joint, parent constrain it to put it in the right position and orientation, delete the constraint and parent it to the follicle, and then freeze transforms. So that's all we're doing here. So I'm just going to select follicles here. Run this guy. And now you can see the follicles are all nicely named. Joints are all named here as well. And they're all in the right spot. You can see they all have the correct orientation as well. Looking good. So what I'm going to do, just to make these look a little bit nicer, I'm going to take the radius down on them. There we go, something like that. Alrighty. So that was pretty easy. So again, strongly suggest you learning Python if you haven't already. It makes rigging so much quicker. And so now I don't have to parent each joint to the follicle. I don't have to do that for any of the other tentacles. I can just do it for, I just click that one button. Alright, so the follicles are all done. So at this point, we can start to set up the controller objects for the ribbon. So easiest way to do that is with a series of joints. So I'm just going to quick create some joints here. Just going to hold down X to grid snap. So there's one. I'm going to create 5 different sets of joints. 1, 2, 3, 4, and 5. I really need that one there. Alright, so these are all the joints that we have here. Alright, 3D orientation off on that. I might just adjust these so they all have the same orientation. There we go. So freeze transforms. There we go. So now they all have the matching orientation. And it's X down the chain, which will go nicely with the follicle there. Alright, so now that I've got the joints, we can bring them to the follicle here. So I'm going to turn off polygons. I'm just going to hold down C so I can snap along an edge here. So this one will go at the very end here. This one will bring right in the middle. 3, 4, 5, 6, 7, 8. I'm pretty sure. So we'll bring one right there. And one right there as well. Alright, so we've got our controller joints all set up here. So we'll just quick name these CT. One control. Control 1, and these are waist joints because it's not affecting the main geometry there. Oops. Numbered it wrong. So this is control 2. There we go. Make sure I'm consistent with the naming here. 4 and 5. There we go. We've got our controlling joints here. Now we just need to make some controls. So as far as making the controls go, actually first we just zero out the X so I make sure they're all perfectly centered here. So that looks good. So as far as making controls go, you can pick whatever you want. For IK controls, I typically like to do something with arrows, something to indicate that it is more of a translate control than it is a rotate control. That's why I typically like the D-pad here. I'll turn that off again. And we'll get these all the right size once we get each one here. There we go. Rotate each of these. Make sure the root tentacle is big enough where it can be seen. Shrink most of these down just a little bit, something like that, where I can still see the control right there. And truth be told, you probably don't need a root control here. I would use this control would only be used in like cases of you just need to make a quick adjustment to where the root of the tentacle is, because there really isn't much room to move around here. And like with each root of the tentacle having its own control here, it can get a little cluttered. But that's why I would only use this in like extreme circumstances. And I'll take these two and shrink them down a little bit more because these are more of kind of like middle controls. Shrink these down a little bit more. And the larger controls here, and shrink them down a little bit. I still want them to be bigger. Than the kind of middle controls here. Bring that down a little bit more. Something like that. There we go. And it's really kind of your personal preference of how you want to scale them or what icons you want to use. Okay, so we got our controls. Alright, so let's do some quick icon padding here. So, and I'm going to give each of these controls two groups above them so that we can constrain them and make some small adjustments to the positioning based on how the character is moving and all of that. So, easiest thing to do just be to constrain or create a double group here. Select the joint, group, parent constrain it with maintain offset off, delete that constraint, and parent the curve underneath, and then freeze transforms. So there we go. So now it has the same orientation as the joint, and it's got the two groups which we want. So now we'll just quick name these. So these are the control pads. I like to make sure I name these control pads as opposed to just a regular pad, which is for joints. And this is underscore icon. I always like to make sure that I have the actual icons with the underscore icon, but the pads for them do not have icon in them. Because let's say an animator wants to select everything that has the name icon in it. Well, if these have icon in the name, they're going to get selected too, and an animator is going to try and key them, and it's going to break the rig. So we obviously don't want that. So that's why I make sure we give it the control pad instead of icon pad. So, and since I don't want to do that for the rest of these controls, we've got a handy dandy tool to do that for us. The icon pad maker. So I click icon, I want two pads, and I want to set it to freeze, which means that the icon is going to stay exactly where it is. Zero out would be for something if I made a generic control at the origin and I just wanted to snap to the joint, that's why I would select zero out. So yet again, showing why Python is so necessary for this. So select the icon, the joint, make pads, and since Yeah, I'll change the name on this. So Control 2. And there we go. So we'll do the same thing. And depending on, I may change the name. So, because 1, 2, 3, 4, 5 would kind of suggest that they're all kind of equal, whereas the middle and end here, or like the middle is going to follow the end and the root, and these ones are going to mostly follow the middle. So maybe to make sure that you understand the priority, I will rename these. So the tentacle root icon, let's do that instead of control 1. So this is part of the rigging process. Let's call this mid. Let's see, mid root. We'll call it that. I do consider this part of the rigging process where, you know, you come across something that might work a little bit better, to go with that. Um, that's kind of the point of doing this series this way, is kind of see, to understand the process of how I go about setting everything up. And, you know, I might make changes as I go. It kind of just depends. And this is really only for personal rigs. This isn't really for like a professional rig, because, you know, you're usually adhering to the wishes of whoever you are working for. So just call this mid icon. We'll call this mid end icon. We'll call this end icon. Something like that. Sure. Rename everything. So yeah, super thrilling here, but this is part of the process. Okay, so we've got our controls. They have the groups. Everything looks good there. So we'll start connecting the icons to the joints using just a simple parent constraint. Maintain offset shouldn't really matter here, seeing as how they have the same position and orientation. So you can pick which one works best for you. Alright, so our joints are now connected to the controls here. Let's quick color these controls, something like that. So again, this is just another shelf button with a loop in it. For those unfamiliar, to color the controls, you go to the icon in the attribute editor here. You go to drawing overrides. You enable the overrides. This will be off by default. Enable it, and then you change the slider to the color. And since it's a central control, I typically use yellow there. Alrighty, so we got the controls. At this point, we can attach the ribbon to these new joints. So select the joint. Oops. Yeah, we can group them too. City tent 1 controls, add something like that. All right, and we'll select these joints. Select that geometry, and we'll go to the bind. Default settings should work fine here, so just quick bind it, and let's see how it looks. So looking pretty good. We'll probably have to make some adjustments as far as the weighting goes, but it's pretty solid. There isn't really much I would change about how the weighting looks here. But now we should probably set up the constraints so that the middle controls will start to follow the root in the end here. So we'll start by getting this main middle control here to follow the root in the end. So select the root, the end, and then the mid control pad. And we'll just do a point constraint. We'll keep maintain offset on. So there is no adjustment here as far as translation goes. And set this 0.5. Now we get the middle moving. And let's do the same with the middle controls here. And that. And the mid-end pad 0. Set it to 0.5. Select middle root, and the mid-root control pad, point constraint, maintain offset on. So now, set that to 0.5. So now if I move everything around, at least it's translating. Now you can see what's going on here. Got a little bit of a wonky setup, and that is because it's translating, but it's not rotating, so we need to set up some aim constraints. So before I do that, because part of the issue with an aim constraint is typically, I like to use object rotation up, and we need a world up object. So we need something to determine if the object that has the aim constraint on it is going to twist in any way. And if so, what is it going to follow when it twists? Now, right now I have the master icon here, which isn't the case anymore. So what I'd like to do is have kind of a center of gravity icon, something that when it rotates, it's going to rotate the whole lower body. So that will be the indicator for the world, for the twisting of the tentacle if necessary. So I'm going to create a quick center of gravity icon. Scale this guy up. This is my default center of gravity. Get it? Because it looks like a cog. So I'm going to kind of move this into the spot I want here, but we'll probably shrink it down a little bit. Something like that. Freeze transforms, and I'll call this CT cog icon for center of gravity. And what I'm going to do is I'm going to actually move the pivot to the bottom of the character, because the pivot here really kind of doesn't matter, because whereas on a normal biped character, the center of gravity's pivot is going to be at the hips. But since this guy really doesn't have any hips, and he's going to kind of move from the bottom here, I'm going to move the pivot to the bottom. Something like that. Just want to make sure I don't go too far, so I use vert snapping just to make sure it's more so on the bottom of the character, just like that. Alright, so there we go. So now this icon is going to determine the world up object for the aim constraints that we're going to do. So we're going to do aim constraints so that these icons are pointing towards each other, and this icon is going to determine if it needs to twist at all. So, with that name plugged in here, So I'm going to set it up so this is the aim object for the middle control here. So select icon, middle pad. The aim vector is which axis is pointing to it, which is the x-axis. I'm going to turn maintain offset on as well so that it doesn't snap. Up vector is the up axis here in this case, which is y, which is good. Object rotation up for the world up vector. We want the up axis for the center of gravity icon, which is y up as well. That's really all we need here. So maintain control pad, aim constraint, maintain offset on, apply. So now you see this icon is actually pointing towards the end control, which is exactly what we want. So we'll do the same thing, similar to what we did for the point constraints. We're going to set it up for the smaller middle controls here. So root control, aim pad, aim constraint, cog icon, all good there. And for this icon, we're going to use the middle icon for the aim constraint. Icon, control pad 0 for the mid root icon, aim constraint. So now, if I move the end control here, there we go. We get it all in a nice little line here. Doesn't even look like there needs to be much adjustments to the weighting here. Maybe a little bit at the end here. But I don't know. I may keep that because I do. If this character's tentacles are going to move kind of in an IK way, I may want the end of the tentacle to kind of stay planted on the ground. So I might keep that actually the way it is. Now, one thing you notice is that the tentacle is no matter where I move this control, the tentacle is pretty straight here, which I don't necessarily want, especially if this is going to function almost kind of like a leg. If there's like a walking hip, I want this tentacle to be able to move forward or move around, and the middle of this almost bends like a knee. So what I want is maybe something automated where, depending on the distance here, I may want this control to move up a little bit, almost to create a tentacle setup. Yeah, I definitely am going to have to need to adjust some weighting here on the ribbon. This does not look good when you look at it in this way. So I would like something, if I move this in, this moves up, almost similar to an IK setup. There's a couple ways we can do that, but I think the easiest way to do it would be with a distance tool. So what we're going to do really quick is create that distance tool. So I'm going to turn off polygons for a sec. So the distance tool, we go create, measure tools, there it is. Measure tools, distance tool. So we'll just create one more. So we have the distance here. So we're just going to snap this, and it's going to be similar to how you would set up like a stretch on an IK arm, something similar to that effect. It's not snapping in the right position to get there. There we go. We got one there. And let's snap the other locator on here. So So I'll call this CT tent 1 bend root locator and bend end locator. One bend distance dimension. Okay, so now that we've got everything named, I'm going to connect the locators to the beginning and end controls of this system. So you can see the distance is matching that. So I want to set it up so as this distance decreases from its default position, this secondary pad here will move a little bit up, something like that. Just to kind of give like the appearance of a bend similar to that of a leg. So easiest way to do that is we're going to open up the node editor. All right, so what we need for the node editor is we need the shape node of the distance dimension here. We'll also need the middle pad of this middle icon here. So CT tent 1 mid control pad 1. And we'll also need the master control icon for the global scale here. All right, I think that's all we need. So we bring this stuff in here. Let's get rid of that shape node because we don't really need it. Okay. So we're going to set this up very similarly to how you would set up a stretchy arm with just a couple of changes here. So the first thing we do is we connect the global scale here. So what this does is it ensures that when we scale the character up, all the values will stay consistent. So we'll set scale x here into input 2x, and we'll call this make sure everything is named consistently. I'll call this global dis for global distance. And what we need here is we need the flat default value of the distance. I don't want to plug the distance in here, but I want to get just the initial default value. So the easiest way to do that is with a little script in the script editor. To be more precise, I want the full number here. This ensures that there aren't any small values that are added onto it. So I want to make sure I get the exact precise number here. So all I did was a getAttr on that distance dimension distance attribute here. And I'm just going to take that value and plug it into the global distance here. There we go. Now we need the local distance. So we'll create whatever is giving me nothing but issues lately. So another multiply divide, plug the output of this into the input 2 of that, and here is where we plug in the distance into input 1. So that'll give us our default 1 value. I'll call this local dist. All right, now in similar fashion with the arm, we create the condition node. call this CT tent1. Always make sure you're consistent with your naming. Makes things a lot easier for yourself in the long run. So we plug in the distance into the first term, and we plug the global distance into the second term. All right. Now we need to get the value. We're going to set this to 0 because we want the default value to be 0 if this is false. And we're going to set this to less than. So when the distance is less than the default value, I want this control to pick up, kind of like how a leg would. So the value that we need to plug in for color of true R, we need to add a couple of things to make sure we're getting the proper value here. Because right now it's set to 1, and I want the default value to be 0 for translate Y on this pad. So the first thing we need to do is we need a plus minus average node. And again, consistent with the naming. And so we're going to plug the output X into input 1D here. And it would also be important if we set this to divide. So now we're getting the proper 1 value here. There we go. All right, so now that we've got the 1 value, we need to subtract 1 from it so that the default value is 0. Now we don't have any second attribute here, but that is easy to come by. So we'll just plug in an additional connection here. So if I click off and click back on, you see we get that second attribute. Now all I have to do is just break connection, and we have the second attribute. I'll set it to 1, and then we make sure that we set the operation to subtract. So that, by default, should give us our 0 value. Now we'll probably need to adjust the value so that it's a little smaller than what we're initially getting, but we'll plug this in to start with so I can show you. So we plug this into color of true R, and then we'll plug the out color R into the translate Y. So there should be a 0 value there for translate Y. Looks good. All right, so let's see what we got. So if I move this back, you see it goes down a little bit. So we obviously want it to go up because we want the bend, because obviously this bend would go through the floor, which it already is doing. So we want that bend to go up instead of down. And we might want to, actually, we're getting some pretty decent distance here as far as the bend is going. I might want to bend it a little bit more because you see it's losing its distance here. So I may actually, I thought I was going to have to decrease the value. I might actually want to increase the value. So we're going to do that with another multiply divide node. And I'll call this, oops, there we go, we'll call this CT tent1 value adjust multiply divide. So I'm going to take this output 1D and plug it into the input 1X here. And I will set this, let's try -2 or -1.5. Let's not go crazy here. So the negative will flip the value so that the icon is going up as opposed to down, and the 1.5 will increase its value a little bit just to see what we get. So now we're just going to take this output X and plug it into the color of true R instead of the plus minus average there. And let's see what we get. So not bad. And now since we got everything connected, I can actually just increase the value myself. So -3 might be a bit much. Let's try -2.5, something like that. That's looking pretty good. Looks like we're getting a decent value there. Now, one thing I also might want to do is actually create kind of an on-off switch for that, because I don't necessarily want this bend to be happening all the time. So what I want to do is just create a simple on-off switch. So create one more multiply divide here, and we'll call this CT tint 1 on off multiply divide, and we'll plug the out value of, or the out color here, and we'll plug the output X into that translate Y to replace the original connection. Now you see it instantly shuts off anything that was going on there. So one thing we need to do is we need to connect something into here to turn it on and off. Now this is where I might actually want to create a new icon, kind of an individual icon, that all the controls and blend shapes and everything will run through that icon. Now again, you can use whatever icon you have your mind set on as far as controls, but let's have a little fun here. We're going to use the CV curve tool here, turn it to cubic, and let's just create kind of almost a tentacle look to the icon here. Much there. Something like that. And we'll close this curve. So we go to modeling, curves, there should be open close there. There you go. So it closes it, and now we've got our little tentacle control here. Now I'll center pivot on here. I can shrink it down a little bit. And if I want to, I can adjust how some of this looks if I'm being a little nitpicky here. So there we go. We've got our icon. So what I'm going to do is I'm going to move this guy right on top of here. We'll drag him up, and we'll rotate him into position. There we go. And this icon is very large. We'll scale it down a little bit. And we'll put it a little bit higher just so that we can kind of make sure that it's there. We'll keep it straight up so that it's not going to intersect with any of the other controls that we make here. And we'll call this CT Tent 1 individual icon. So that'll just let us know that this is the control that's the individual level control that's going to control everything here. So we can create our attribute. So edit, add attribute. So to turn it on and off, the best attribute to use is a Boolean. If you want just a quick switch to like on or off, this is the best one to do. If you want to have some level of like blend in between them, the float may actually be the better option here. So what we'll do, we'll use a float just so that the animator can have somewhat control over the switch between them. So we'll put this as tentacle bend default 0, max 10, and just like that. And as far as connecting it in, there's a bunch of ways that you can go about doing it. You can either use a set-driven key, or you can use a set range node. Kind of up to you. I prefer the set range node, um, just because it's a lot easier to adjust things with a set range node. That's just me, though. By by all means, if you would rather use a set-driven key, you are more than welcome to do that. So a set range node that I've used plenty of times before, it's kind of a manual set-driven key almost. It allows you to take an existing value and adjust, take the range of a value and adjust it into a different range. So I'm going to add this guy in here. There you are. Okay. So we'll plug the tentacle bend into the value here. And so the old min and old max for x is 0 to 10. And we'll just convert the new min and new max x from 0 to 1. And we just plug that in to this input 2x here. There you go, it should multiply it by 0 until the icon is active. So if I move it right now, because the attribute is set to 0, you're going to see no bend here. So if I activate this bend, now you see we're getting the bend. So now we can get kind of a walking character almost. So if you want the character to walk, you can place the tentacle on the ground and have it walk. And it'll look much better once we got the rest of the tentacles using this method as well. The last thing I want to do before we end the ribbon, this part of the ribbon tutorial, is I just want to clean up the ribbon itself, because you can see it's still a little bit choppy. We got some bumps here. It'd be nice if we could clean this all up. So what we're going to do is we're going to go to the Paint Weights tool. And we're just going to clean up. I'm going to start by smoothing some of these values. There we go. Just smoothing it just a little bit, just so it's not as bumpy as it was. Just clean it up a little bit. And we'll eventually have to go into the component editor as well. Right now it's just a lot easier to visualize the bending and get it to how we want it to look, and then we can make the adjustments in the component editor. So already you can see a much better improvement over the look of the ribbon. So I may leave this part of the tentacle where it is, because I do want like the tip of the tentacle to stay kind of planted on the floor. So I'm not going to smooth over here, but I will smooth right over here. Alright, so you can see a much better look to the ribbon as it bends. And at this point, all we really need to do is clean up these values because I want the values on either side of the ribbon here to be exactly the same, so that way we don't get any, unwanted twisting of the joints. That can throw it off a little bit. I want these to be perfectly even as far as values go. So start, let me turn off joint selection so I don't accidentally click on a joint. And we'll close the node editor here, and we'll open the connection editor. Nope, not connection editor. Sorry, this sounds so similar. Component editor. There we go. Let's shrink this window down. So all we really need is this. So what I can do is I can get rid of any of the unwanted values here. So the first three controlling joints here don't really need any sort of value here. And I'll just plug a really low value. I'll just do like 0.01, something really small. But now you see the numbers are all consistent. That way we ensure that there is going to be no unwanted twisting there. So same thing. Don't need tentacle 3, turn that off. Let's find a nice middle ground value. Let's do 3.38. 3.382. Something kind of in the middle here between all of these. So at this point, this value is slight enough where I'll keep it in there. 0.01. And let's do 0.3 for this. So there's even values there. And these values are low enough. I'll just take this out. 3, okay, looking good. Set this to 0.13. That should just be a straight 1 value for this joint. Let's turn these off. We don't need 5 at this point. 0.195. I'm just kind of picking kind of an average number to set these values to. You don't have to do anything crazy here. Don't need tentacle 2, tentacle 5. And let's set this to 0.537. And I know this is tedious and this isn't very exciting, but I want to make sure that it's as precise as can be, so that we avoid any twisting whatsoever on these, any unwanted twisting. I want to keep this as clean as possible. Let's values off there, and do 0.22. Try to speed this up a little bit here. Okay. Almost at the finish line here. 2. You can see, because we're getting it all even, you see the ribbon is no longer twisting there. So that's exactly what we're looking for. Don't need any of this extra stuff here. 5. Almost done. See, there's some pretty big separation in the values here. Don't like that. So put this at 0.11. let's just check the other side here. These all should be set to 1. Or this guy. Alright, everything else looks good here. Alright, so we've got the ribbon nice and clean here. You can see by the movement we're getting here, the ribbon looks much smoother than it did before. And now we have a nice little leg bend here. So as the character's tentacles move around, we can get a little bit of a leg bend here. Now, if you wanted to, you could set this up with a, you could have like an IK joint system here, and then connect these icons to those if you really wanted to. To me, that just felt like you were adding some stuff that you didn't necessarily need, because we can achieve it with these controls just kind of on their own. So looking pretty good, and we can adjust the on-off value here, so we can turn it off if we want to. All right, so we got the tentacle pretty much set up with the ribbon. So since this video has gone on insanely long, for the next video we'll go over building all the blend shapes for the ribbon and connecting all of that in there, as well as setting up a master control for all of the tentacles at once. So on to the next video.